Number 4-7, factoring completely. Now we're going to take all of our factoring techniques such as greatest common factoring, difference of squares, using sums and products, mentally. We're going to take all of that and we're going to use it to factor out expressions. The first step in factoring success is to look for a greatest common factor. Once you've got out your greatest common factor, you need to factor the resulting polynomial. If you've got two terms, is it a difference of squares? If so, factor it as such. If you have three terms, you can either use the sums and products in your box, or you can do it mentally. Mentally works if we've got a coefficient of 1, but that's not always true for our x squared term. So remember, you have to factor until you can't factor anymore. And just because if you can't factor any further doesn't mean your original expression is prime. If at the very beginning you can't factor any at all, if you can't find a greatest common factor, if you can't use sums and products or difference of squares, then yes, it's prime. But if you do factor out something, then you factor out something, it's not prime. Now let's think here. Let's see if we can find a common factor. Well, all of the terms have an x, at least one, so we're going to be able to factor out an x. And all of the terms are also divisible by 3. So we'll go ahead and write out 3x, since that's what our greatest common factor is going to be. Now let's think. What times 3 would give us 6, or what is 6 divided by 3? 6 divided by 3 is 2. What times x would give us x cubed? Or we took one x away from this x cubed, we were left with an x squared. If you were to multiply these two terms, you would see that you would get 6x cubed. Now let's think. What times 3 would give us back 3? Or 3 divided by 3 is 1. So we can go ahead and think. And then what times x would give us x squared? In this case, x. Or we've divided x squared by x. Go ahead and multiply 3x by x, you get 3x squared. Now, what times 3 would give us negative 18? In this case, negative 6. Negative 18 divided by 3 is negative 6. And then, what times x gives us x? Well, that's 1. Negative 6 times 1 is still fine. So now we've got a trinomial. The coefficient isn't 1, so let's go ahead and write out a box. Fill in what we have. We've got the 2x squared and the negative 6. If I were to multiply 2x squared and negative 6, I would get a negative 12x squared. So our two resulting boxes are going to have different signs. And they're going to sum up to our middle term. In this case is a positive x. Factors of 12, I can think of that have a difference of 1 would be 4x, 3x. And then since we want a positive product, the 4x should be positive. That makes a negative 3x. So we'll go ahead and work with 4x and negative 3x. X times x will give us the x squared. Now right here, we can also factor out along this side the 2. So now we've got 2x times x makes 2x squared. What times 2x would give us 4x? In this case, it would be a positive 2. What times x would give us what times x would give us negative 3x? Well, in this case, a negative 3. And then negative 3 times positive 2 makes a negative 6. So now this can be rewritten as 3x times the factors of 2x squared plus x minus 6, which are 2x minus 3 and x plus 2. So this is the completely factored form of the original expression. Going on to number 2, let's see if we can find a common factor. Well, 5 goes into both 5 and 5, and they both have at least one x. This one has an x. So whenever you're doing your greatest common factoring, the smallest amount of x's is usually going to be the ones you can pull out. But remember, all of the terms have to have an x if you're going to factor out an x. All of the terms would have to be divisible by 5 to factor out a 5. So we can factor out 1x. So what times 5x would give us 5x cubed? Well, we've got 1 and an x squared. If you were to check, 5x times x squared, 5x cubed. And then we factored out a 5, so we've got a negative 1, and then we also factor out an x. So what times 5x would give us negative 5x? Negative 1. So all that's really going on when we factor out a greatest common factor is we end up dividing. 5x cubed divided by 5x is x squared. Negative 5x divided by 5x is negative 1. If you were to distribute this, you would see that you would end up with the original product. Now, if you'll notice, this is a difference of squares. So we can write our other factor. And we've got x plus 1 times x minus 1 using our shortcut pattern. And this cannot be factored any further, so this is the fully factored form. Looking on to number 3, I see that I could factor out a 4 out of both of these. And this term doesn't have an r, so there's no r to factor out. So let's factor out a 4. 8 divided by 4 is 2. I didn't do anything to the r squared. And then negative 4 divided by 4 is negative 1. Now, this is not a difference of squares because 2 is not a perfect square. There is no two numbers multiplied by themselves, so let's say 1 times 1 would give us 1, and then 2 times 2 gives us 4. There's no whole number that you can multiply by itself to get 2. So this is not a difference of squares, so this is the fully factored form of this question. Going on to number 4, let's see if we can find a greatest common factor. Well, 2 does not go into 11 or 15, so we've got no number, and 15 doesn't have a z to factor out. So there's no greatest common factor in this case. But this does look like a quadratic trinomial, so let's go ahead and use our box method. We've got the 2z squared and the positive 15. 2z squared times positive 15 makes a product of 30z squared. So far so good. Now I can think of sums to would be our middle term of negative 11z. So let's think of factors of 30 that would add up to negative 11. Since they need to add up to a negative number, they both have to be negative. I can think of negative 6z and negative 5z. They multiply out to 30 and add up to negative 11. So we can go ahead and fill in our box. We've got the negative 6z here and then the negative 5z, here. So z times z will give us our z squared. And along here we can factor out a 2. So we've got 2z times z makes 2z squared. 2z times a negative 3 would give us the negative 6z. And then z times a negative 5 would give us negative 5z. And just to verify, negative 5 times negative 3 makes a positive 15. So now we've got factors of z minus 3, and then 2z minus 5. Sorry, that minus is a little sloppy. So this is the fully factored form of number 4. Going on to number 5, let's see if we can factor out. We've got all of these terms are divisible by 4. 4 goes into 8, and into 44, and to 28. And they all have at least one n, so there's a 4n I can factor out. So what times 4n would give us 8n cubed? Well, 2 times 4 gives us 8, and n times n squared. So all we did was took away one n from here, and then we divided by 4. Multiply these, make sure that you get your original factor. Then we've got a negative 44 divided by 4 makes a negative 11. And we took out one n, so n times n would give us n squared. 4 times negative 11, negative 44. And let's check for 28. 28 divided by 4 is a positive 7. 7 times 4 is 28. And we took away one n, so n divided by n, what times n would give us n? 1. 7 times 1 is still 7. So we've got another quadratic trinomial. Let's go and fill in our box. And we've got 2n squared and a positive 7. So that would give us a 14 n squared for our multiplies to. And for sums to, we're going to have a negative 11. Now, let's see if there is any factors of 14 that have a difference of 11. Unfortunately, for this case, only factors we can think of, let's see, we've got 7 and 2. We also have 1 and 14. And that's it. None of these add up to 11 or have a difference of 11. 1 and 14, if you subtract them, make 13. If you add them, make 15. If you subtract these, you get 5. If you add them, you get 9. So no factors work. So this expression right here is prime, but your answer is not prime. This is your answer. We still factored out something, so this original expression was not prime because there was a greatest common factor. So this is our answer. This trinomial is prime, but our entire answer is not prime since what we started with was not prime. We ended up factoring out something. But don't forget, don't write prime if you can't factor something further, unless your original expression is what you can't factor further. But in this case, we could factor out a 4n, so this is our answer. Now let's think for number 6. We've got 4v squared minus 40v plus 36. So 4 will go into 4, and 40, and 36. And this 36 doesn't have a v, so all we can do is factor out the 4. So 4 divided by 4 is v squared. Negative 40 divided by 4 is negative 10, and still leave the v. And then we've got 4 divided by 30. 36 divided by 4 makes a 9. Now we have one that has a coefficient of 1, so we should be able to factor this mentally. We can start thinking outside of the box. We need factors of 9 that would add up to negative 10. So since they need to add up to negative 10, well, let's go ahead and fill in. We've got the v times the v will make the v squared we need. We need factors of 9 that would add up to 10. Since this is positive, they have to add up to 10. But since this is negative 10, they both have to be negative. We've got 3 and 3, that makes 6. That doesn't work. What about 9 and 1? 9 and 1 make 10. So we need a negative 9 and a negative 1. V times v would be v squared. V times negative 1 makes a negative v. Negative 9 times v makes a negative 9v. So we've got a negative v and a negative 9v to make a negative 10v. And the negative 9 times negative 1 makes a positive 9. So this is the fully factored form of number 6. Finally, we've got one review problem. The problem says the sides of a piece of a cardboard in the shape of a right triangle are in the ratio of 5 to 12, 13, 5, 12, 13. If the perimeter is 60 feet, what is the length of the shortest side? So let's think. If we want the perimeter of a triangle, we end up adding all of its sides together. Now we've got, let's pick a variable as a scale factor. We've got x as a scale factor. So for instance, if the shortest, let's say if we wanted to pick the side as 1, if x is our scale factor, and let's say we picked in 1. Well, the sides would be 5, 12, 13. If we were to pick, let's say, 3, we would need to multiply each side by 3. So if your scale factor was 3, 5 times 3 is 15, 12 times 3 is 36, 13 times 3 is 39. So it would be 15, 36, 39. But let's think. Since we don't know what our scale factor is, we're going to end up adding all the sides together. So we've got 5 times the side, plus 12 times the side, plus 13 times a side. Our scale factor, our scale factor is equal to our perimeter of 60 feet. We're not sure what our scale factor is. It could be 1, could be 2, could be 3. We can solve for x, though, by combining all of our like terms. Since these all have the same variable and same exponent, we've got 5 plus 12 plus 13. If we add that together, you would get 30x. So we took 5x pieces, 12x pieces, and 13x pieces, put them all together to get 30x pieces. You keep your base and your exponent and then add the coefficients. Set that equal to 60. We divide each side by 30. We're left with x is equal to 2. So now we can verify. If we've got 5 times 2, that makes 10, plus 12 times 2 would make 24, plus 13 times 2 would make 26. 24 plus 26 makes 50, and then 50 plus 10 makes 60. So yes, our perimeter works. Our scale factor is 2. So in this case, our shortest side would be 10. So 10 feet is the length of the shortest side. Hopefully you understand a bit of more factoring completely. We just take all of our steps that we've used. So once again, to review, look for a greatest common factor. From then on, if you've got 2 terms, the difference of squares. If you've got 3 terms, use your box or do it mentally. Sometimes we might even encounter 4 terms, and that you should probably use factor by grouping. That's all for today's lesson.